In order to find the most suitable ways to extinguish fires, they have been classified into 5 simple categories. Class A for ordinary combustible materials such as wood, paper, clothes, etc. Class B for oil and other flammable liquids. Class C for gases. Class D for fires in metal. Class F, Class K in the US, for burning cooking oil. Click on the symbols for. Under normal conditions, Class A material, such as wood, paper and clothes, do not give off vapor that can be ignited. But if wood and paper are heated by a few hundred degrees, ignition can take place. Fortunately, Class A material is fairly easily cooled below its ignition point, when it will cease to give off flammable vapor and combustion will end. Therefore, the best way to extinguish a fire involving Class A material is water, applied in the form of a spray. This table summarizes the use of different extinguishing agents according to the actual fire categories. Class B fires are fires with oil and other flammable liquids. Oils have a wide range of flash points. As far as ships are concerned, they may vary from -30 degrees centigrade to more than 60 degrees centigrade. Obviously, oils with a flash point as low as -30 degrees centigrade cannot be cooled below their flash point by applying water, in spray or any other form. For this reason, cutting off the available supply of oxygen by covering the surface with foam is considered to be the best method for extinguishing an oil fire. Until the present day, CO2 and halon have been in regular use. Due to the ban on halon since the 1st of January 1995, new alternative gases have come out on the market. All inert gases work by limiting the oxygen supply to fires in enclosed areas. Inogen, Argonite, NN100 and Argotec are examples of inert gases. Halon is an inhibitor. It is important to note that in North America the classification system is slightly different than the international system, and that in North America Class C is used to designate electrical fires. Even though both gas and electrical fires can be extinguished with CO2 or halon, it is still important that these different classification systems are not confused with each other, since these two types of fires have different characteristics. Class D fires are comparatively rare and usually require special extinguishing methods. Powder extinguishers can also be used and are equally efficient if it is possible to reach the source of the fire. Class D fires are fires that involve metals such as magnesium, titanium, potassium, lithium, calcium, sodium, uranium, plutonium, as well as other flammable metals. These fires burn at extremely high temperatures, are highly reactive, and can easily spread to other materials in the surrounding area. Many common firefighting agents, such as water or foam, can actually excite these types of fires or cause an explosion. Firefighting gases, such as halon or CO2, can react with the fires, releasing toxic gases such as phosgene, fluorophosgen, or carbon monoxide. Dry powder is the recommended extinguishing agent for Class D fires, though there is no single extinguisher agent that is approved for all Class D fires. There are several types of Class D agents, and it is important that the agent to be used is compatibility approved for the material that is burning. Dry powder must not be confused with dry chemical agents, as some dry chemical extinguishing agents can also excite these types of fires. Common dry powder agents include sodium chloride granules and graphite or copper powder. These agents work by smothering and heat absorption. Operation of these extinguishers differs, and it is important that the operator has received training specific to the equipment being used. Class F fires involve cooking oils or fats. They are different than Class B fires in that they have a higher auto-ignition temperature and are much harder to extinguish than typical flammable liquids such as petrol. In order to extinguish a Class F fire, the temperature must be lowered below the auto-ignition temperature and the flames must be extinguished. This makes extinguishing such a fire with a non-class extinguishing agent very dangerous due to the high level of heat. Use of water on this type of fire is very dangerous, as it will result in an explosion, spreading the burning oil as the water is quickly converted into steam. Conventional foam is not always effective either, because the high temperature quickly destroys the foam blanket, exposing the surface of the oil, which can result in reignition of the fire. CO2 and ABC extinguishers are also ineffective, since they do not seal the surface of oil from oxygen, and any flames put out by such extinguishers are likely to reignite. Such extinguishers also pose a risk of spreading the fire due to their discharge force easily spilling the oil onto the surrounding area. Class F extinguishers are either wet or dry chemical-based, and in some cases foam-based with special additives. Their blanketing effect is similar to that of Class B extinguishers, but with greater cooling effect. They work by reacting with the burning oil, creating a soapy layer on the surface that both cools the fire and prevents the flammable vapors from reacting with oxygen. Class F extinguishers should, however, not be used on Class B fires, since their extinguishing agents only react with animal fats and vegetable oils. Water is normally the most suitable extinguisher to fight Class A fires. Water extinguishes the fire by cooling it below the ignition point. That means it removes the heat side in the fire triangle. Water is a very important extinguishing agent on board. It is cheap and easily available in large quantities. In spite of the many types of fire extinguishing mediums now available, water is still a suitable overall substance for extinguishing all fires, provided it can be applied in sufficient quantity. Water is supplied to the hoses via the fire mains from the pumps. Click on the buttons to learn more. Portable water extinguishers can be used as an effective tool in reducing or controlling the spread of fire. The water reduces the temperature of the burning material below its ignition point, thus extinguishing the fire. The most efficient way to extinguish fire is by water spray. When applied in the form of spray, the water evaporates to remove the heat and cools the burning substance below its flash point far more rapidly than if applied by a jet. In addition, the wide angle provided by the spray will protect the firefighter from the heat of the fire. Applying by spray. Normally, you should combat fire by spray. When applied in the form of spray, the water evaporates to remove the heat and cools the burning substance below its flash point far more rapidly than if applied by a jet. The fire hoses are placed in cabinets together with their nozzles. You will find a fire hose connection close to the cabinet or inside the cabinet itself. The nozzle is a combined jet spray nozzle. Fire cabinet. The fire hoses are placed in cabinets together with their nozzles. You will find a fire hose connection close to the cabinet or inside the cabinet itself. The nozzle is a combined jet spray nozzle. Sprinkler system. A sprinkler system is normally used to protect the accommodation area. It extinguishes or prevents fire by spraying water from nozzles in the ceiling. Depending on the system, the sprinkler system is activated manually from the bridge or engine room, automatically when a nozzle is exposed to heat. Fire pump and hydrant. The fire pump will supply water to the fire hoses via the hydrants, the sprinkler system, the foam system, the fire pump is started from the bridge or the engine room. CO2 extinguishes the fire mainly by cutting off the oxygen supply. CO2 gas does not conduct electricity and is the most suitable medium for extinguishing electrical fires and operates on the principle of smothering the fire by displacing the oxygen. CO2 is available through a fixed installation system and portable extinguishers. Click on the buttons for more information. The master, in close liaison with the chief engineer, will make the decision to use the fixed CO2 extinguishing system. Before releasing the system, the following shall be carried out. The CO2 alarm must be put into operation. All ventilation should be closed. All engine room fans and ventilation must be stopped and fire flaps closed. All CO2 protected areas are evacuated. The engine room, paint shop and incinerator room must be completely evacuated and ensure that all personnel are accounted for. The system shall only be released on the master's order. Grab the insulated part of the discharge horn. Be aware that the CO2 discharged is extremely cold, -78 degrees Celsius. So always remember to grab the insulated part of the discharge horn and use caution in the event that you must use the extinguisher on someone that is on fire. The extinguisher should not be discharged close to the skin, and directly spraying onto sensitive areas such as the face should be avoided. When using a CO2 extinguisher, sweep the discharge horn across the fire. The discharge time for a 6 kilo extinguisher is about 20 seconds. Foam extinguishes the fire mainly by cutting off the oxygen supply. Foam is available through hoses and nozzles, portable extinguishers, and fixed foam guns. Click on the buttons for more information. Foam is especially suitable for use on flammable liquids, such as oils, paints, etc. Let the foam find its own way over the burning liquids. The foam should not be discharged into the burning liquid, but directed at the opposite wall of the area in order to flow gently over the surface, thus forming a seal, which prevents the vapor mixing with oxygen. Foam must be applied continuously and without interruption. The foam equipment consists of one foam storage tank, one foam monitor, one booster pump for firewater. Foam production requires foam concentrate and water. Concentrate is mixed with water at the proportionator. Air is drawn in and mixed with the solution to produce foam at the foam hydrants and monitors. At the proportionator, concentrate is mixed with water from the fire main at a rate of 3%. The resulting foam solution is fed to the foam monitors and foam hydrants on deck. Here, air is drawn in and mixes with the solution to produce foam. Powder breaks the chain reaction in the fire triangle. Dry powder is useful in dealing with liquid spill fires. The medium has, however, no cooling effect, so the danger of reignition must be considered. It might be necessary to cool the material with water after the fire has been put out. Powder is suitable for electrical fires as well. Since dry powder is non-conducting, it is suitable for electrical fires as well, but not so well suited for fires involving free-burning materials where the cooling effect of water is needed. Click on the button for more information. Dry powder system. Powder systems are used on board gas carriers for the protection of the deck area. The dry powder system extinguishes or prevents a fire by covering an area with powder, which reacts chemically with the fire. The powder is released from the storage tank through powder guns. The system is activated from designated release areas. Halon 1301 is listed as a CFC gas. As of January 1, 1994, Halon systems are not installed on board new ships. Halon systems are used to protect the engine and pump room. The Halon 1301 system extinguishes fire in the protected space by releasing halon gas, which reacts chemically with the fire. It is activated from designated release areas. Powder breaks the chain reaction in the Halon 1301. You are now going to watch a video. Pay close attention, as you will be asked to complete some tasks when the video is finished. Select the fire extinguisher you find most suitable in this situation. CO2 extinguisher. This is a correct alternative. In this situation, CO2 puts out the fire efficiently and there is no pollution. However, if you have the pot lid nearby, the most suitable way to put out the fire will be to place it on top of the pot and remove the pot from the heat. Powder extinguisher. This is a correct alternative. Powder puts out the fire efficiently in this situation, but does cause dust pollution. A. Water extinguisher. This was the wrong alternative. As you've seen, never use water, especially in the form of a jet, on burning liquids.